Bismillahirrahmanirrahim. Hi everyone. I hope you are all fine. I welcome you all in class of real analysis by Walter Rudin. In last lecture, we discussed existence theorem for a for any positive real number that can be stated as uh, if x is any positive real number and n is a positive integer, then there exists a unique positive real number y such that the nth root of x is equal to this unique real number y, that can also be written as x is equal to y raised to power n. In today's lecture, we will discuss Corollary, and the second one we will discuss extended real number system. This is the Corollary available in your textbook of Walter Rudin. This Corollary says if a and b are two positive real numbers and n is a positive integer, then the nth root of the product AB is equal to product of their nth root. That is, AB whole power 1 by n is equal to A whole power 1 by n into B whole power 1 by n. To prove, we suppose that the nth root of A, as A is positive real number and n is a positive integer, so it must be that its nth root exists. Suppose its nth root is alpha and the nth root of b is beta. Then a into b, from here you can see here, if you take power n on both sides, this gives a is equal to alpha whole power n. Similarly, from here you can write it as b is equal to beta whole power n. Now taking the product a into b, as a is alpha raised to power n and b is beta raised to power n. By combining, we have alpha into beta whole power n. As a and b both are positive real number, it is given, so their product a into b is also positive. So by the uniqueness assertion of the theorem 1.21, we have as AB is a positive real number and n is a positive integer, so it must be that its nth root must exist. The nth root of AB must exist. So its nth root is given by AB whole power 1 by n. Taking power 1 by n here, we have as AB is equal to alpha into beta whole power n. This gives alpha into beta by cancelling out the power n into 1 by n. Hence, this shows that by substituting the values of alpha and beta again, we have AB whole power 1 by n is equal to A raised to power 1 by n into B raised to power 1 by n. So this is the simple corollary that I hope now you have a clear understanding about this corollary. Next, we discuss the extended real number system. This is the definition 1.23. This is very simple definition. If x is if x is any real number, then in the real number system R, that you can be defined as, this is the open interval from minus infinity to positive infinity. Both endpoints minus infinity and plus infinity are not included in set of real number R. So if x is any real number, then in the real number system, this x lies in these two symbols. If the set of real numbers we include the symbols minus infinity and plus infinity, then the resulting number system becomes a closed interval minus infinity less than or equal to x less than or equal to positive infinity. This real number system is called actually extended real number system. So the only difference between real number system and extended real number system is that in the real number system, your real number lies between these two symbols minus infinity and plus infinity, and these two symbols are not included. While if we include these two symbols, then the resulting real number system now called extended real number system. Further, in some textbook, the extended real number system is sometimes denoted by R over bar or R steric. Thus, the extended real number system is actually the union of two disjoint sets. First is the set of real number, and the second is the set. This is this set of two symbols minus infinity and plus infinity. It is assumed that R star satisfies the following axiom for any real number x. Further, I am writing here some important axioms or properties of extended real number system that is satisfied for any real number x. The first one is that for any real number x that lies between minus infinity or plus infinity, if we add x with infinity or if we add infinity with x, then the result is only positive infinity. Subtracting x plus minus infinity and minus infinity plus x, this is equal to minus infinity. By adding infinity with infinity, this is equal to infinity. Although this property does not hold in usual real number system, in the system of real number we cannot say that infinity plus infinity is equal to infinity. But in the extended real number system, because you have now included infinity, so that's why infinity plus infinity, this is equal to infinity. Minus infinity plus minus infinity, this is equal to minus infinity. Minus time infinity is equal to minus infinity. Minus into minus infinity, this is positive infinity. If x is any positive real number, and if you multiply the positive real number x with minus infinity, because x is positive, so it will not change the internal sign. This is remains same, that is minus infinity. Similarly, minus infinity into x is also minus infinity. But if x is a negative real number, and when you multiply x with a negative infinity, now it changes its sign and it becomes plus infinity. Similarly, minus infinity into x, this is plus infinity. In case if x is a negative real number, and if you multiply x into minus infinity, this is positive infinity. In other words, if you these there is no need to write the last two properties. This property can cover these last two properties. If you multiply 0 with positive infinity, this is equal to 0, and if you multiply infinity with 0, this is also equal to 0. And this property also does not hold in usual real number system. In the usual real number system, you cannot say 0 into infinity is equal to 0. Actually, you change this form into indeterminate form. So similarly, 0 into minus infinity, this is also equal to 0. Minus infinity to 0, this is also equal to 0. Infinity into infinity, this is equal to infinity. However, these operations are also undefined in extended real number system. That is, if we add infinity with minus infinity, there is no answer of this operation. We cannot say that infinity plus minus infinity, these are the additive inverse of each other, so this becomes 0. This is not equal to 0. This is undefined. Similarly, minus infinity plus infinity, infinity into minus infinity, minus infinity into infinity, minus infinity into minus infinity, these are operations are undefined. There is no answer of these operations in extended real number system. Next, I am sharing some important facts about extended real number system. In extended real number system, the first one is, it is important to note that we cannot consider plus minus infinity as a real numbers, although these are included in extended real number system, but they are just symbols. Because in extended real number system, you write r star is equal to, this is minus infinity close interval to plus infinity close. This is your extended real number system, and both of the endpoints are included in this system, but still we cannot say that these are the real numbers. Only those numbers that lies between these two symbols can be considered as real numbers. The further one, this is also very important and can be asked in your Viva Voice exam. Set of extended real number system R star does not form field, because there are many axioms of field do not hold in R star. For example, the additive as well as multiplicative inverses of plus minus infinity do not hold in R star. For example, if you say what is the additive inverse of plus infinity, if you say this is minus infinity, this is wrong. Minus infinity is not the additive inverse of this. Similarly, what is the multiplicative inverse of infinity? If you say this is 1 over infinity, this is wrong. Further, there are several property like as the Closure property, Closure law does not hold. You cannot say that infinity minus infinity. This is undefined operation as I have discussed above. So we cannot say that the answer of this operation belong to R star. Similarly, the distributive laws properties also does not hold in the extended real number system. So finally, the extended real number system do not fulfill the axiom of field. So this is the simple story about extended real number system, and now I hope you have clear understanding about extended real number system and the two-day corollary. So inshallah, in the next lecture we will discuss another important topic from this book. So if you find this lecture is helpful, kindly like, share. So see you in the next lecture. Take care. Allah Hafiz.